Hello, it's Mr. Guffick here, and welcome to our next video on our A-level preparation. And we're looking at, for Edexcel A-level, this is a tricky type of differential equation exam question. This one I think is particularly tricky, and it's the kind of question that would be A star, and it would be at the end of a paper. So let's have a look at this differential equation question. So it says, a scientist is studying a population of mice on an island. The number of mice n in the population t months after the start of the study is modeled by the equation n is equal to 900 over 3 add 7 e to the minus 0.25t. Find the number of mice in the population at the start of the study. Okay, so that's going to be when time is equal to 0. So we're going to have n is equal to 900 over 3 add 7 times e to the 0, which is going to be n is equal to 900 over 3 add 7. So n is going to equal 900 over 10. So there's going to be 90 mice on the island at the start of the study. Part B. Okay, this I think is really tricky. Show the rate of growth is given by that. So we've got to differentiate our n expression, and to help it look a bit more straightforward for our differentiation, I'm going to rewrite it as this: 3 add 7e to the minus 0.25t to the minus 1. So all I've done is just rewritten 900 over as 900 times something to the minus 1. Okay, so this is just a different way of writing n. So now when I differentiate dn by dt using the chain rule, I'm going to have minus 900 over 3 add 7 e to the minus 0.25t. Okay, so I times by the power it's there and lower the power by 1. So the minus 1 goes to minus 2. And then I've got to times by the derivative of the inner function. And that's going to go to 7 e to the minus 0.25t because the 3 disappears. And then remember, because we're using the chain rule, we've got to times by the derivative of the inner function. So we also need to times by the derivative of that, which is going to be minus 0.25. Okay, so that's my expression differentiated using the chain rule. So I multiplied by the minus 1, lowered the power by 1, times by the derivative of this inner function. The 3 disappeared, leaving me with that, but then I had to use the chain rule again to times by minus 0.25. Okay, so we've got that expression there, and it looks kind of really complicated in terms of knowing how we're going to deal with this. So let's think about how are we going to deal with this. Let's go back to our original equation. Now, there's various methods for solving this question, but I'm just going to go through one of the potential approaches. So the original equation in the question was this. Now, if I swap those two over, then I can basically say that 3 add 7e to the minus 0.25t can be rewritten as 900 over n. So that is 900 over n. So that's just from rearranging it there from the original equation. So now I'm going to sub that into this expression that I've got here. Okay, so if I take that result and sub it into here, I can now get that dn by dt is equal to minus, well, that minus and that minus will cancel to give a plus. So it's plus 900 over 900 over n all squared. Okay, so what's happened is I've just changed the 3 add 7 e to the minus 0.25t squared is the same as 900 over n, just from the original equation. So I've now got that dn by dt is 900 over n all squared. Okay. Now, let's think as well about the original equation. We could do with saying, let's see if we can replace that with something. So let's park that there. That was the idea that was used to get rid of that. Let's go back to the original equation again now. So we've got n is equal to 900 over 3 add 7 e to the minus 0.25t. And this time I'm going to rearrange this to try and get an expression to get this on its own. So I'm going to times by the 3 add 7e to the minus 0.25t, like that, is equal to 900. I'm going to divide by the n again, so that will disappear from there and go to over n. And then I'm going to subtract 3. So I get 7e to the minus 0.25t is equal to 900 over n minus 3. So that's just revisiting the original equation and doing a little bit more rearrangement again so that I can get this expression to replace the 7. So we've dealt with that, there's our 900. We've dealt with that, there's our 900 over n squared. We're now about to replace this. This is now getting replaced by 900 over n minus 3. So 900 over n minus 3, like so. So that's great. So we've dealt with that. And we've still just now, we're timesing by, we've just got that we're still timesing by 0.25. Okay, that's looking really good now. I think starting to look like we could be getting somewhere. So let's think about how to simplify this now. Well, remember, dividing by a fraction is the same as timesing by its reciprocal. And I'm going to do that 900 times by 0.25 as well. Let's just do that. So 900 times by 0.25 is 225. So that goes to 225. So that's gone and that's gone. And then dividing by a fraction is the same as timesing by its reciprocal. So that's the same as 900 over n squared rather over 900 squared. So I've just taken the reciprocal of that, because dividing by a fraction is the same as timesing by its reciprocal. And I'm now timesing by 900 over n minus 3. Okay, let's see what is this 225 over 900 squared. So 225 divided by 900 squared is 1 over 3,600. So I've now dealt with that, and that is looking n squared times by 900 over n minus 3. Okay, starting to look a little bit better. We're kind of almost getting there now. So let's continue. So now what I'm going to do is I'm now going to expand my brackets. So I've now got, let's see what we've got. We've now got that dn by dt is equal to n squared times 900 over n minus 3n squared. So I've just expanded the bracket by doing that times that and that times that. That cancels, that cancels. I've got my 1 over 3,600 as well from before. So now I've got 1 over 3,600 times by 900n minus 3n squared. And from here, I can now factorize out an n, and there is a common factor of 3 in all of the terms. Okay, so if I divide that by 3, divide that by 3, divide that by 3, then I get 1 over 1,200. I'm going to take out a common factor of n as well, and that leaves me with 300 minus n. Okay, so we've now got our expression. So just to repeat, what's happened here is I've divided every term by 3 because 3 is a common factor. And remember, it's perfectly permissible to do that because this whole thing is a fraction. So as long as you divide the numerator and the denominator by the same thing, that is okay. And then I factorized out the n. So we've now got what we were after, which is n, open brackets, 300 minus n over 1,200 is equal to dn by dt. As I say, quite a tricky rearrangement, I thought, there for that question. So that is, believe it or not, only worth 4 marks. Okay, so that's our part B done for 4 marks. Now, but again, remember, this is like right at the end of the paper, so it is like A star. What does it say now? It says the rate of growth is a maximum after t months. Find, according to the model, the value of t. So let's think about this. So we've got, we need to be looking at when we've got a fraction, it's the numerator that's going to be telling us what's going on in terms of the maximum. Okay, so we're particularly interested in this 300, n times 300 minus n. That is what we're particularly interested in. And let's just imagine we had a little, I think the most useful way to think about this bit is to visualize if we had a graph here. This numerator is a negative quadratic with dn by dt would equal 0 at when n is 0, and it would equal 0 when n is 300 as well. So dn by dt would equal 0. There would be 0 growth when n is 0 and when n is 300. And then by symmetry, we can conclude that the maximum amount of growth will occur when dn by dt is 150. Okay, so the maximum growth rate is going to be 150, which we can conclude by the symmetry of our negative quadratic that we've got in the numerator. So we can say then that this maximum growth is occurring when we've got a value of 150. Okay, so let's have a look. So we're saying dn by dt is a maximum of 150, and that is equal to our 900 over 3 add 7 e to the minus 0.25t. So we're just going to solve that now for t. So swap those over. So we have 3 add 7 e to the minus 0.25t is equal to 900 divided by 150. So I've got 900 divided by 150 is 6. And then I'm just going to rearrange this now to make the subject, t the subject. Okay, so I'm going to have 7e to the minus 0.25t is equal to 6 minus 3. And then I'm going to divide by 7. 6 times 3 divided by 7. Okay, so I end up with e to the minus 0.25t is equal to 3 over 7. Take logs of both sides, and I've now got minus 0.25t is equal to ln of 3 over 7, and then divide by minus 0.25. So 1 over minus 0.25 ln 3 over 7. And that is our answer when we rearrange it. So let's, when we solve it rather. So we put that into, well, actually, to be honest, they will accept that as an answer. It's perfectly fine. Or you could put it in your calculator and work it out. And that turns out to be 3.4. 3.4 is the answer for that one. Find the maximum, find according to the model the value of t. So t is equal to 3.4 to 1 decimal place. 1 decimal place. Okay, so that's part C done, which was a much nicer 4 marks than the previous bit. Now, according to the model, and this is our old favorite thing here, according to the model, the maximum number of mice on the island is p. State the value of p. Now, again, you know, I can't emphasize how important this is. We've come across this so many times. So let's have a quick look and go back to some of our previous working. So going back to some of our previous working, if we look at the original equation, looking at the original equation, n is equal to 900 over 3 add 7e to the minus 0.25t. Remember, this negative exponential looks like that. It's got that kind of shape. When you've got e to the minus something, we have exponentially decaying. So as t tends to infinity, e to the minus something tends to 0. Okay, so what does that mean for us? It means that as n gets bigger and bigger and bigger, the equation essentially becomes 900 divided by 3, and that term completely vanishes because it becomes 0. Okay, so we end up with 900 divided by 3, so we end up with n is equal to 300. And that is our final answer for state the value of p. Quite a tricky question of its type, I think, that one, especially in my opinion. The part B with the rearranging there was not at all nice. A lot of work for 4 marks. I hope that you found that video useful, and I will see you in the next video.